Fundamental data structures. A data structure can be defined as a particular scheme of organizing related data items. Data structure explains how data is actually organized in a manageable format. There are two types of data structures: linear data structure and non-linear data structure. In linear data structures, we have array, linked list, stack, queues. In linear data structures, data are arranged in linear fashion, one by one. Second one is called as non-linear data structures. In non-linear data structures, trees and graphs, dictionaries, etc. First one is array. Array is actually a sequence of n number of items. All the items are having the same data type, and these are actually stored in contiguous memory locations in a RAM. These elements of the array are accessed by using an index value. Index value generally start from 0. So in array, the first index is called as 0 and the last index is called as n-1. It is also possible sometimes index start from 1 and the last element called as n. In some situations, the index can be a non-numerical values, just like string value. One of the advantage of array is we can access the element of the array using a constant amount of time, regardless of where actually the element is located. That means we can access the first element with the same amount of time from the second element or the fifth element or maybe the last element. The time taken for the array is same. This is one of the best advantage of array. Array is faster, more efficiently compared to others. Next one is called as linked list. In linked list is actually a sequence of 0 or more elements. The elements are called as here nodes. Each node contains two parts. The first part is called as information or data. The second part is called as a link or a pointers. This pointer is actually pointing to the next node in the list. A special pointer called as null is actually indicating there is no any more node in the next, means there is no any successor node is available. That is indicated by null. Null value is actually added to the pointer to the last element of the list. In singly linked list, each node except the last one contains the next node. For example, see here actually it is a pointer which is pointing to this node. This pointer is pointing to the next node, but at the last there is no any pointer is available. One of the disadvantage of this linked list is the amount of time needed for accessing the element is depending on the element location. If we are accessing the first element of the list, it will take less time. If we are accessing the last element of the list, it will take more time. So this is one of the disadvantage of linked list. Linked list has advantages also. In linked list, the space is not reserved in advance. Whenever we need a node, the extra space is allocated. So the space need for the linked list is less compared to array. And one more advantage of this linked list is insertion and deletion of the node is very easy and efficient. If you want to just add a new node here, just pointing that, just use that pointer to the next node and this pointer to this node, that is insertion will be done. So insertion can be done by just changing the pointers. So this is the advantage of linked list. The disadvantage is it will take more time to access the element, but advantage is it will save the space. When less number of data is there, it will save the space, and insertion and deletion will be more efficient one. One more variation of the linked list is called as doubly linked list. In doubly linked list, each node contains two links or points. One is generally pointing to the previous node and another is actually pointing to the next node. Only the last and the first nodes are having only one pointers. Another pointer is actually null value. Stack is a list in which insertion and deletion can be done at one end, called as the top. That is, only one end we can insert the data, at the same end we can delete the data. When we add the new element, it is called as pushed onto, means pushed operation. When we delete the data from the top, it is called as pop the data or popped off. The insertion and deletion operations can be done in only one top positions. The element which is added last is the element which is deleted first. So it is also called as last in first out. In short, LIFO. One more type of linear data structure is called as queue. In queue, the elements are inserted from one end and deleted from another end. The end from which the data is inserted or the element is inserted, it is called as rear end. The end from which the data is actually deleted or removed, that is called as front end. The deletion operation is called as DQ, and the insertion operation in the queue is called as NQ. In queue, the data which is inserted first is removed first. So it is also called as first in first out. In short, it is called as P4. First element is inserted, is removed first. So it is called as P4. Some note here. Arrays. By using arrays, we can implement a variety of other data structures. For example, we can create a string by using array. String is nothing but an array of characters. At the end, a special character is added which is indicating the end of the strings. Sometimes these strings are containing only two values, zeros and ones. Such strings are called as bit strings or binary strings. One more note is here. We can create a linked list and give some more functionality to the linked list. That is called as exploit flexibility. Means we are giving some more function to the linked list by adding a special node at the top. That special node is called as header. This header node actually contains some information about the linked list, such as the number of nodes in the list, the first node pointer, the pointer to the last node. Such information is stored in the header node.